All right. This video shows you how to run a factorial ANOVA in SPSS. I'm using the dataset goggles, and so you could follow along if you'd like. And let me explain this data set real quick. So it's fake data. It's kind of silly data. It's taking two nominal variables, face type and alcohol, and using these two nominal variables to predict a continuous outcome. And so the first one, face type, is we're grouping face types into unattractive and attractive. And so there's two groupings, and then the alcohol, we're actually going to be giving people, um, alcohol-free. So basically, a placebo, and then a low dose, and then a high dose. And so this is alcohol consumption, I think is the full label for this. And so again, we're using those two variables to try to predict how do people rate the attractiveness of a face. Okay, again, silly example, but and you'll notice that for each of these, for face type, there's just two options, and for alcohol, there's three options. So this would be a 2x3, or you can also say a 3x2 ANOVA. So the two refers to the first variable, face type, and the three refers to the three groupings on alcohol. And it's an ANOVA because it's using, it's a factorial ANOVA because there's two independent variables. These we think are the causes of how a person evaluates the attractiveness of a face. Okay, so the first thing to do with a factorial ANOVA is to evaluate the assumptions. The first one is random sampling. So this one I've told you before. Go ahead and just assume that that's the case. We assume we have a sample that we put together through random selection. The second one is measurement scale, and I've already kind of walked through that. We have two nominal independent variables. So for factorial ANOVA, they have to be nominal, and there has to be more than one. Otherwise, it would be a one-way ANOVA. And then the dependent variable is continuous, and so it's measured on scale. So that's good. So we've met the first two assumptions. The third one is normality of the dependent variable. And so to do that, you just run descriptive statistics, descriptives, and then just move that over here. Click OK. And you have the descriptive statistics here for, oops, I forgot to run the skewness and kurtosis. So just remember you can click those here, and OK. And here we go. So skewness is negative 0.78 and kurtosis is 0.66. Both of those are within -1 and 1. So this is normally distributed. Of course, the last assumption is the equality of variance assumption. Now, this is actually the way that we're doing it for our class is you only test this if the interaction is not significant. If the interaction is significant, you don't worry about this. So, and the fact is you already run this as part of the factorial ANOVA, so I'm just going to put it off until we do the factorial ANOVA. All right, to get to the factorial ANOVA, it is a comparison of means, but we're actually going to go a different route. We go to Analyze, and then this is the general linear model, and we're going to go to univariate. We obviously have three variables, but only one dependent variable. That's why it's univariate. So the dependent variable is going to go here, and then these two are going to be fixed factors. All right, and we need to click a few things. So we need to click on plots, and I like to do this two different ways so that you could see it. So one, and then the reverse, and I'm going to do it as a line chart for both of them. Post hoc. Now we don't need to do it for face type because there's only two groups. There's attractive and unattractive. If you get a significant result, you know it's because the unattractive is different from the attractive. So you don't have to do a post hoc test for that one. But alcohol, you do need a post hoc test because there's three groups. So you don't know if it's the first is different than the second, or the second is from the third, or first is from the third. So we're going to do that, and I'm like the Chaffee, so I'm going to do that. And the options is the other one, and I like clicking this one and this one and continue. All right, so that provides us with this output here. We can see that there's 24 unattractive faces, 24 attractive faces, and then they offer the participants alcohol, or at least most of them alcohol. A third of them get the placebo, a third of them get low dose, and a third of them get high dose. So you could see the different means, right? So the attractiveness is higher for attractive than for unattractive. That makes sense. And then you can also see placebo, low dose, high dose. There's a trend that the attractiveness is getting higher as the dose of alcohol increases from nothing to a little to more. And so we see some trends, but the question is, are these just random chance, or is it possible that these differences in means are the result of a real effect? Now, this is the equality of variance. I'm going to skip this because in the way we do it in our class, the first step is look at the overall model. In SPSS, it calls it the corrected model. All right, so this is significant. So we've passed step one. We have determined that the corrected model is significant. Now, the second step is to look at the interaction. We see the interaction here. There's this asterisk that says it's the interaction between face type and alcohol. And what do we see? Well, actually, this is significant. So we get a p-value of less than 0.05, and therefore this is significant. And what that means, well, before we get into like how to interpret it, it means that we don't have to check our fourth assumption, which is up here. It would have been okay if the interaction was not significant, but because this is significant, you just totally ignore this one. All right, so what does this mean? It means that the effect of one variable depends on the other. So how alcohol impacts attractiveness ratings depends on whether the face type is unattractive or attractive. And I think the best way to unpack this is actually to look at the graph. So if we come down here, all right, so again, we have two graphs. I'm going to start with this first graph here. So if you, here we go. If you receive the placebo, you rate the unattractive face much lower than you rate the attractive face. If you have the low dose of alcohol, you do rate the attractiveness of the unattractive face as lower than the attractive face, but it's not as considerable as the difference here. But then finally, if you had the high dose of alcohol, so if you are drunk, you have the potential of rating on average the unattractive face equally, if not a little higher, right? This is a negative slope, so it's a little bit higher than the attractive face. So again, this is fake data, but it's suggesting that if you're drunk, you might actually find attractive an unattractive face. So what do we see here? This is the attractive faces, on average, they're about the same. It doesn't really matter if they receive the placebo, the low dose, or the high dose. But if the face is unattractive, right, that's that blue line here, then it does very much matter if they drink alcohol. Okay, so again, that's how you could unpack this, right? Alcohol potentially can make a unattractive face attractive. All right, so that would be our takeaway from this. And the way we do this in our class is actually we stop there. We actually don't go any further with this. So we actually can say that there is a significant interaction between face type and alcohol. If you're really looking into the data, you would actually look at these other variables, but for this class, just to keep it simple, that's where we'll end. All right, I'll wrap up here, and what I'm going to do is I'm going to upload another video showing how to write this up, and hopefully that'll be really helpful. So I'll stop here.